In this video, I want to explain something kind of complicated. Students usually have a hard time figuring out how does the heat shift the equilibrium and which way. So you've got this color change and you know it's this color in hot water and this color in cold water. How do you figure out if it's exothermic or endothermic? Please do not think about the reaction just being hot because you put something in hot water or the reaction being cold because you put it in cold water. That's the effect, not the cause. So don't get confused between the cause and effect in science, and especially with equilibrium. So first, let me show you a demo. Hello everybody. In this video, I'm going to demonstrate how heat can be used to shift an equilibrium, either left or right, however it's written. And we're going to use a thermochromic reaction found in color changing nail polish, all right? So let's focus in on the chemistry here. I've got two different beakers here. On your left is the hot water and on your right is the cold water. So here I am starting out with, it looks like, you know, just kind of like a white kind of color here in the video. And if I place this into cold water, it changes pink, as you can see, all right? Kind of a nice kind of pink. All right, so it has a pink color in cold water and it has more or less a white color in the hot water, okay? So we'll analyze this. My other popsicle stick has this, I don't know, let's call this black. Black, let me put it on the white background here. This is kind of like a black color. And I'm gonna place this into hot water here, okay? And there's a shift. Let's call this purple, all right? Just for the sake of discussion, that's purple in hot water. And when I place this into cold water, it changes black, all right? So now let's discuss the thermochemistry of this. All right, so here's the thermochromic reaction number one. Thermochromic, by the way, thermo means heat and chromic means color changing. So it's a color changing reaction. So thermochromic reaction number one, we had in hot water, we had this white color, and in cold water, we had this pink color. And so I'm writing the reaction there, A in parentheses white, in equilibrium with B, which is pink. So is this endothermic or exothermic? How do we solve this riddle? All right, there's two ways. First, you can do it by trial and error. So let's randomly try placing heat on, I don't know, the left. All right, so write heat on the left. Now pretend like we use heat as a physical substance. So step two, you just want to check the hot water result, okay? If we increase the temperature, that's the same thing as adding heat, remember? And remember that if you add heat, it's going to shift away from the increase or shift right, okay? And that's not right, because in hot water it was white, it was not pink, all right? So we know this is wrong, so we fix it, all right? Now we put heat on the other side. There's only two possibilities, so let's put heat on the right side of this equation and check it. If we increase the temperature, we're adding heat, right? And the reaction is therefore going to shift away from the increase or shift left. And let's think about that. Yes, that's what we observed. In hot water, we saw a white popsicle stick, and in cold water, we saw pink. All right? Also, check the cold temperature. This is how you do that. So if we decrease the temperature, what happens? Well, we're removing heat in cold water, right? We're removing the heat, and so you shift towards the decrease. So this also is going to shift right, and that's correct. Okay, so we figured it out. Now that we know heat is on the right of the equation, we can say it's an exothermic reaction. All right, thermochromic reaction number two, we had this black popsicle stick in cold water and a purple popsicle stick in cold water, all right? Now, the other way to do that is just rationalize. Just in your mind, think and figure it out without doing trial and error, okay? So we know that heat is going to push it to the right, which is the hot appearance, okay? So heat's going to be on the opposite side of the chemical that's hot, all right? Purple is the color of the nail polish in hot water, So we know that the heat is going to be on the opposite side of the reaction. Okay, so let's put heat on the left now. And then, of course, you want to go through and check, hey, does hot water shift to the right? Does cold water shift to the left, and all that, okay? All right, so I just want to final mention here, if you have a reaction heat plus A in equilibrium with B, you can say that it's endothermic because the heat is on the left side of the equation. If it's on the left, it's endothermic. If it's on the right, it's exothermic. That's all. You don't have to think about the reaction heating up or cooling down, okay? Now remember, any reaction can be written flipped. If you flip the reaction, it's going to be exothermic, okay? So if we have purple in equilibrium with black, heat's on the right now, and we would call that exothermic because heat is on the right, okay? I hope this video helped you. If it confused you more, please send me a message and I'll try to help you out.